Hello junior scientists, welcome back to our YouTube channel. I am your Raj sir. Today our topic reflection of light, plane surfaces and curved surfaces. The both cases reflection takes place. A reflection of light. Plane surfaces, curved surfaces, both are there. So in our daily life, do you have idea about the plane surfaces means that is only our plane mirror. Every day we are seeing our face in the plane mirror. The next curved surfaces means bike side mirrors, car side mirrors. Okay, so those are called curved surfaces, convex mirror and concave mirror, right? So in this video we'll discuss about the what is the property involved in the light to takes place reflection in both cases, right? So now first I am going to the plane surfaces. Here this is the plane mirror, right? So in this plane mirror, what happens? Here you should know about the minimum idea about the incident ray, point of incidence, normal, reflected ray, and angle of incidence, angle of reflection, angle of deviation, angle of glancing. So these things you should have minimum idea about it. Reflection, either plane surface or curved surface, both, right? So the knowing terminology is very important, right? Then only able to understand the terminology of the light. Yes, children. So now I am going to explain about the terminology. Then after we go to the curved surfaces, right? So now here we have the tools, scale, and compass. Okay, so these are the tools. So when you are drawing, you also maintain compass. Geometry must compulsory, right, children? So what I am doing now, one see here. I want scale here, right? So this is a plane mirror. Sometimes this plane mirror will be treated as M and M dash. M and M dash. Plane mirror is treated with the M and M dash. Is plane mirror. The light source, light, laser light. The light is projected like this, right? So if your light is projected on the plane mirror, then what happens? You have done the activities also. Once observe the carefully. So now this is called incident ray. Incident ray, incident on the plane mirror, right? So I am considering this point is capital A and this point is capital B. A, B. Now AB is incident ray. At what point this AB strikes the plane mirror? This plane mirror, the incident ray strikes at certain point. That point we call it as point of incidence. AB is incident ray. At this point of incidence, we have to draw the normal, right? So this point of incidence I am taking as O. I am taking as O, and next at the O point we have to draw the normal. We have to draw the normal, right? So I am drawing here normal at the point of incidence. See, exactly. This is the normal. ON is the normal. ON is the normal. Next, the angle between, now we got angle between incident ray and normal. The angle between incident ray and normal is called angle of incidence. That is shown with a letter small I. Right. The next, after incident ray rebounces like this. So now that is nothing but reflected ray. Okay. So just approximately I'm taking here the shape of V shape. This is the reflected ray. So the name of reflected ray, just I am considering the 2 points C and D. The CD is the reflected ray. Incident ray, normal, and a reflected ray. And next, now we got angle between ON normal and CD reflected ray. The angle is considered as angle of reflection. Angle of reflection R. Okay, this is the main basic phenomena behind reflections. Okay, so it may be simple, but conceptual understanding is very important. Always incident ray, reflected ray makes equal angles with the normal, right? For example, I value 30 means R value also 30. I hope you understood. So this is the reflection involved in the plane mirror. So we understood incident ray AB, and O is the point of incidence, ON is the normal, and CD is the reflected ray, and next I is the angle of incidence, the R is the angle of reflection. Then what about angle of deviation? Angle of glancing. Angle of glancing means the angle made by the incident ray with the plane mirror, with the ground, right? So here incident ray is making angle alpha. Incident ray is making angle alpha with the ground. So now this alpha is nothing but a glancing angle. Here also same angle. Okay. So why? Because we have to consider some angles, then it will be easy. Nana. See once. Here I value, I am considering this as 30 degrees. I am considering this as 30 degrees. Then what happens once? See here. If I value is 30 degrees, R value also 30. Why means that is laws of reflection law. This law is followed by the light ray. Here 30. So total normal is making 90 degrees with the plane mirror. So that's why the remaining angle is 60, 30, 60 and 30, 60. Okay. So that's why glancing angle equal. Right. So then after here, what is angle of deviation? What is angle of deviation means? Here only one thing. What is that means? See children, here this is the incident ray. This is the incident ray, right? So here if there is no mirror means what happens? It will go like this same path, right? So it will go in the same path. If there is no mirror, it will maintain the same direction, but because of mirror it rebounds. Okay. So for example, there is a ball. Okay. So I am throwing like this. So if you kept any one pad, then it rebounds. Otherwise it will maintain the same path. So that is nothing but here this is the extended incident ray. So actually extended incident ray we have to denote it with the dotted lines. Okay. So we have to denote it with the dotted lines, but I am taking here a path, but it doesn't go. Now what is mean by angle of deviation? The angle of deviation means it is the angle between extended incident ray and reflected ray. What I told you should go in this way, but how you are going? You have taken direction like this. So you totally deviated, your direction changed, your direction takes place anti-clockwise direction. How much degrees, how many degrees? See once here glancing angle 60. Do you know what about this angle? Yes, we know. How we know? And this angle both are vertically opposite angles. See, this is one straight line and this is one straight line, and this angle both are vertically opposite, right? So that's why this angle also, this one also 60 degrees only. And if you consider the symbol also, this is alpha means this is also alpha. Children, we are getting angle of deviation. Conceptually we are discussing. If you get any objective type of questions, everything for IIT foundation also you will get it, children, right? So here alpha plus alpha, 2 alpha, angle of deviation d is equals to 2 alpha, right? So otherwise here I plus I is equals to r, right? So one more formula for angle of deviation is equals to 180 minus 2y. So these are the formulas for the angle of deviation. I hope you understood. Okay, pause the video and copy the content. We are going to the next slide. Right. So here already we discussed the reflection rays, right? So but here what is what we are discussing here? Laws of reflection. Laws of reflection means we have two laws, first law and second law. What is first law? What is second law? Very simple. First law is telling a lie on the same plane. What lie on the same plane? I am taking here incident ray and reflected ray and normal lie on the same plane. Incident ray AB and reflected ray CD and ON normal. These three lie on the same plane. Lie on the same plane means what? Lie on the same plane means what? These three lie on the same board now, right? So now this board is plane surface, lie on the same plane. So first point is cleared, right? The next point what? Second law, I is equals to R. So as per laws of reflection, here how much angle of incidence, that much angle of reflection. For example, here 30 means 30. So I is equals to R. I is equals to R. Angle I is equals to angle R. Right? So I hope you understood. You don't think this is very slow, but children, this is a conceptual understanding. Then if you get the numericals or any concept, then you are ahead. Alright. So that one shot or shortcuts, fast track revision, we will discuss it later. Right. So now in this slide, we'll discuss about the spherical mirrors. Spherical mirrors, we have two types of mirrors, that is concave mirror and a convex mirror. Concave mirror means here bulged out surface, outside surface. Convex surface is silvered and concave surface made smooth, and this concave surface acts as mirror. That's why the name has given for this mirror is concave mirror. Convex mirror means this outside surface is convex surface. Convex surface acts as mirror and concave surface is silvered, means applied paint or coated with a paint. Then such type of mirror acts as a convex mirror. Right, children? Here what I am going to tell you, how to draw the ray diagrams. So ray diagrams, just I am dividing into two parts. One is ray rules. One is ray rules. Another one is image formation figures. You have somewhat little bit confusion. Ray rules, image formation figures. Ray rules means only if incident ray is parallel to principal axis, then after reflection, complete the ray diagram. Complete the ray diagram. Sometimes it asks. So based on ray rules. Okay. If you know the ray rules, then only you can draw image formation figures. Okay. రే రూల్స్ వస్తేనే ఇమేజ్ ఫార్మేషన్ ఫిగర్స్ వస్తాయి మనకి. ఓకే రైట్. సో మనం వచ్చేసి ఫస్ట్ మోస్ట్ ఆఫ్ ద స్టూడెంట్స్ గెటింగ్ స్ట్రగుల్ వైల్ కన్స్ట్రక్టింగ్ ద రే డయాగ్రామ్స్. వెరీ ఈజీ వే చిల్డ్రన్, యూ షుడ్ హ్యావ్ బోత్ దిస్ స్కేల్ అండ్ protractor and pencil compulsory to draw this. You can draw the beautiful pictures if you follow the steps. All the students, how many students are drawing this, you will get all equal same figures, identical diagrams, you will get it. Okay, it's not a handwriting. Okay, just you have to follow the instructions, right? So let me show you how to take the values. Once see here, so this is a scale, right? Here our scale also, if you observe here, somewhat 360 degrees means this is parallel to the horizontal, right? So now it is 0. So while drawing, take the scale properly. 0 parallel to, right? So very simple, don't worry about it. Simple. First step 1, step 2, step 3, how to draw the concave mirror, right? So in your notes also, so very simple, how I am telling you, like that you should take it. Okay. So in your notes, you take the radius 4 centimeters, it is sufficient. Otherwise radius 6 centimeters also accepted. 4 centimeters or 6 centimeters. I will show you with the 4 centimeters. Okay, right. So now what we have to do? See, first what we have to do means, first we have to draw the principal axis. Step 1, principal axis. Okay, see, I am drawing the principal axis. Principal axis completed. After principal axis, mark a center. Mark center, right? See here, I am taking 4 centimeters, right? So it may be small here, but I am taking as 8 centimeters here or 6 centimeters. I am taking 6 centimeters, I am marking here. 6 centimeters means at 3 centimeters of focus. Okay, so once see here, this is 6 centimeters and this is 3 centimeters. If you take 4 centimeter, 2 centimeter take at focus. Why? Because midpoint, right? Yes students, here what we have to do now, I am taking this as, what is this, center, and this is focus. First mark like this, center and focus first. Okay, then after take the compass, here, see once. Now this is radius. How much radius we have taken? For example 4, take 4 centimeter radius, and here 4 centimeter radius, right? So already we have to mark here pole also. This is the pole, focus and center of curvature. Okay, only once ఒక్కసారి జాగ్రత్తగా నేర్చుకోండి, then after that it will be easy. Here now this is the radius, right? Radius, right? So now this is the radius, but it should be like this for me. So take the center here. This is the pencil, right? Right. From the center, we have to draw the arc. Right. From the center, this is a rounder. With the help of rounder, from the center, radius 4 centimeters, we have to draw an arc. Right, like this. See, getting excellent diagram. So draw an arc. Now this is nothing but curvature. Okay, so concave mirror, just we have taken curvature. Then after, what we have to do here? This is the concave mirror. How I am shading like this, you also mark it. So this is the how to construct the concave mirror. The same way, convex mirror also, take the center, from the center radius, draw an arc with rounder, compass. Very simple way. Okay, so now this is the just outline diagram of the concave mirror, right children? Next, so we will discuss ray rules in PPT. For example, draw a parallel ray to the principal axis means, once if you observe, sir, how to draw parallel ray means you will keep scale and you will draw like this, right? That's not the correct way. Once you observe this other edge also, it may be coincide or whatever it may be, this length principal axis should be parallel, right? So here see parallel. At that time only you have to draw the ray. Now this is nothing but parallel ray. Okay, so these like this we have to draw the ray rules. Let me explain one thing. This is, sir, show that laws of reflection means this is the AB is the incident ray. This is the point of incidence O, and how to identify the normal. How to identify the normal means here. How to identify the normal means we have to join point of incidence and center. We have to join point of incidence O and center. Then you will get the point of incidence and center. We have to join. Then only we get the normal. See, this is the normal. Okay, this is the normal. It's very easy. How to draw the perpendicular line means at this point of incidence, if you draw the tangent and radius both are perpendicular to each other. So that's why this radius is acts as normal. Alright. So as per laws of reflection, so I is equals to R. Angle of incidence I is equals to R. So angle of incidence I is equals to R. This 30 degrees means remaining angle, reflection, angle of reflection also 30 degrees, right? So that's why here what we will get means the reflector ray goes through the focus. It is passing through the focus, and angle of incidence and angle of reflection both are equal. I is equals to R. So this is the concept of reflection, laws of reflection. First law or second law, whatever it may be, incident ray, normal, reflector ray lie on the same plane, and after angle of incidence is equal to angle of reflection. I hope you understood. Then we go to the ray diagrams. So total conceptual explanation completed regarding light. Right, students. Next slide. Now, once you see this concave mirror, convex mirror, ray rules. Okay, so now fast. Here, how I draw these diagrams, already I told you. Take the 4 centimeter radius from the center, draw an arc, then may mark here exact midpoint of 4 centimeter, 2 centimeter. Here, mark it, and it is the, what is this? It is the focus. Okay, compulsory use the rounder and take center of the compass, center only. Okay, most of the students, they will draw, they will keep somewhere center, you won't get it. Okay, so follow the rules and instructions carefully, right students? Now very simple way we will draw the diagrams as students. So first ray rule is, if the incident ray is parallel to principal axis, then what happens? Just now we discussed, if the incident ray is parallel to principal axis, then what happens? The rules we are learning, if the incident ray is passing parallel to the principal axis, it is after reflection, it passes through focus. Okay, so ray direction is very very important. Incident ray direction, reflected ray direction, right? So this is the first ray rule of the concave mirror. Converse and similarity will be there here and here. What is converse? Here the incident ray direction is same. What is incident ray direction? Incident ray is parallel to principal axis. Now this is the principal axis, parallel to principal axis. If incident ray is parallel to principal axis, then what happens? Right? Incident ray is parallel to principal axis. Incident ray parallel to principal axis. After reflection, what happens? What happens? It seems to coming from focus. Evaru chepparu enduku? And you may have doubt, right? Here. After reflection, it seems to coming from focus. See here. It diverge from focus. Parallel ray. Incident ray is parallel to principal axis. After reflection, it seems to coming from focus F. Why? Some students have doubt. Sir, why sir? Reason means, again we have to explain the laws of reflection. What is that laws of reflection means? I already told you, we have to draw the normal. To draw the normal, point of incidence and center we have to join with a scale. Radius only we have to consider that point radius we have to consider. Okay, now the scale, pencil, children, you can draw neatly. Okay, right, see. Now this is the normal. Alright. This yellow color is the normal. If you observe normal, it looks like an angle bisector for this angle, right? That's why here this angle is angle of incidence I, and this angle is angle of reflection R. This angle is I and this angle is R. I is equals to R. Again here convex mirror also following laws of reflection. Based on laws of reflection only we are getting the reflected ray direction. This is the conceptual understanding. Sir, idantha నాకు అవసరం లేదు బట్టి కొట్టేస్తా అంటే that is your wish. Okay, I hope you understood. We are going to the next slide. Here also already we mentioned in the previous case, we have to join this like this, you get the normal I is equal to R. Right children. Next, ray rule 2. Incident ray is passing through focus. Here also incident ray is coming towards focus. Why? Because it's come towards focus, but it may not go right. Incident ray is passing through focus. So first we have to take incident ray, how it is going. Incident ray is passing through focus. Incident ray is passing through focus. Incident ray is passing through focus. So here incident ray direction compulsory mentioned. After what happens? Directly after it is parallel to principal axis. After reflection, it is parallel to principal axis. This is the rule. Sir, incident ray is passing through focus means we can take one more ray, any more rays also we can take. After reflection pass parallel, after reflection parallel to principal axis. Okay, so that is the rule. Incident ray passing through focus, after reflection parallel to principal. Why? Because again you have to draw the normal I is equals to R. Okay. Next one, incident ray is coming towards focus. Why? Because it may not enter into the mirror. Here mirror stops the light ray. So that's why here what is the incident ray direction? incident ray direction is coming towards the focus. Coming towards focus. Incident ray is coming towards focus. Incident ray direction coming towards focus. Here there is no mirror means it will go. There is no mirror means it will go through the focus, but there is mirror. The mirror is stopping incident ray direction through focus towards focus. After reflection parallel to principal axis. Here also the same thing, parallel to principal axis. Okay, so here also you can see the error. Parallel means we have to set to 0, but we are getting here. But how do you you will get angle here parallel scale, you will make some angle, that's why you will get some mistakes, but that is not considered. No problem, no issue. Okay, right. So after reflection it is parallel to principal axis. Yes, we are getting the excellent diagrams, right? Yes, children. Okay, so if you are good at ray rules, then you can skip the video, and you can go to image formation figures. I hope you understood. Next, incident ray is passing through center. Incident ray is passing through center. Incident ray is passing through center. Then what happens? The incident ray is passing through center. Incident ray is passing through center. Actually, it takes from long distance, right? Incident ray is passing through center. Incident ray is passing through center. So in this case, what happens means this is the radius, right? Normal incident ray coincide. So that's why again it reflect back. Okay, the same scenario we can take here also. The incident ray is coming towards center. Incident ray is coming towards center, right? The incident ray is coming towards center. The incident ray is coming towards center. Then after reflection, it is reflect back and rebounds back. Okay, here just dotted lines we have to represent. Okay, some of the students mostly what they will do towards center means they will take here only. Okay, in which direction it is going they don't know. Always you coincide with center and draw, will get the clear picture. I hope you understood. 3 rules completed. There is one more rule is also, but incident ray is strikes at pole, again it reflect with I is equal to R. Okay, sometimes in some textbooks also there. What is that? So is it clear? If it is clear, then ray rule 4 also I am going to explain. Okay, what is ray rule 4? See once ray rule 4, what is the heading? Here I don't have one more slide, just I am explaining in this slide only. If the incident ray strikes at pole, then what happens? The incident ray strikes at pole, then what happens? This one point of incidence and center, and this is the angle of incidence I, right? So then what happens means here this one it will make the same angle and it will reflect. I is equals to R. If the incident ray strikes at a pole, wherever it strikes, it follows the laws of reflection. I is equals to R, students. Here also, if the incident ray strikes at a pole, then what happens? Incident ray strikes at pole, then what happens? And draw this at this point or normal. Normal means radius. So now this is only normal. Principal axis itself normal. This is the angle of incidence I. So as per laws of reflection, the light ray reflects. As per laws of reflection, light ray rebounces. So now this is the angle of reflection R. So if the light ray strikes at pole, then we get this is the picture, the ray rule 4. In some of the books you can see. You can take any textbook, any question bank, any reference book, you get the things done. Okay. So pause the video and draw the diagrams neatly. Right. So now we are entering into the topic. Object placed at infinity. Object placed at infinity. So these are the final output, but first we have to draw the image formation figure. Concave mirror image formation figures. Right. So how we get the image in the object at infinity. Okay. Right. Here I am taking this figure help. See, if the object at infinity, okay, This both cases discussed, just I am taking this one. The object at infinity, what happens? Want scale, right? Scale. If object at infinity, we get the parallel rays. Object at infinity, we get the parallel rays. Okay. The object at infinity, we get the parallel rays. Parallel rays are parallel to the principal axis. These parallel rays, after reflection, what happens? Ray rule, first ray rule. What is first ray rule? After reflection, passes through focus. After reflection, passes through focus. Passes through focus. Here, this parallel ray also, after reflection, passes through focus. This is the clear picture. Incident rays parallel to the principal axis, after reflection they converges at focus. So from this what we can say? Object, a distant object, infinity object, the object is taken as sun. Sun is at infinity, right? So big object, so here there is an image of the sun is at the focus. Okay, so next for this, what are the nature of the image? Object position, object placed at infinity. Where is the image formed? Image formed at focus. Right, students, here for this case write the nature or characteristics of the image, means we have to remember these points. So we have concave mirror 6 cases, concave mirror 2 cases. For each and every case we have to remember the nature, but conceptually by seeing this picture you can get it clearly. So here we don't need compass, right? Right. So nature is very important. If you have the conceptual idea, then figure is in the mind. If the figure is in the mind, we can write the nature, right? So simply remember. Nature means should in your mind remember the PS. PS for police station. P for police, S for station. Police station, it's like a code. PS, remember. First P means what? Position. Where is the position of the image? This total regarding image. Where is the position of image? Image is formed at a focus. The reflected rays converging at focus. Where the reflected rays meet, that is the position of image. Reflected rays ekkada meet aithe akkada manaku image form ainattu. Position of image is at focus. Size highly diminished. Real and inverted. Okay. So real and inverted, this is everything. The next case onwards you will get it. Okay. Next one. You see here. Case 2. Object placed beyond C. Object placed beyond C means what? Right? Then how to take the measurements? First of all, you should take these measurements, right? I already shown with a big figure. We have to take the 4 centimeter radius and 2 centimeters, mark the 2 centimeter focus from the pole, right? So object placed beyond C. Then after you take the object. I'm taking object beyond C. Beyond C means where we have to take. Beyond C means where we have to take. Means we have the values also, right? So I'm taking here. I'm showing you for understanding purpose. So 0, pole means 0, and this is at 2, and this is at 4. So here between 2 and this is 3, right? So that's why here 6, at 6 centimeters you take the object. Why I'm telling these numbers means you'll get the clear picture. Okay, clear picture you will get. See children, I'm taking the object. I'm taking the object at 6 centimeters. Right? At 6 centimeters. I'm taking the object from the pole. Okay. How much height? That is your wish. Here 4 centimeter radius means you take 3 centimeters or 2 centimeters. Okay. So like this. How much this height is there? Like that. The next, we have to follow the ray rules. To draw the image formation figure of the concave mirror, object placed beyond C, focus and center beyond C. So what is the first ray rule? That is, first we have to take the ray 1 is parallel ray, right? Parallel ray we have to draw from the tip of the object. Incident ray is parallel to principal axis. After reflection, what happens? Passes through focus. After reflection, passes through focus, right? Incident ray. After reflection, passes through focus. Incident ray, reflected ray. Incident ray parallel to principal axis. After reflection, it passes through focus. First to ray rule 1. Let it be R1, incident ray. Next R2 ray you have to take. R2 ray, R3 ray. Rule 2, rule 3 ఏదైనా యూజ్ చేయొచ్చు. ఇక్కడ ఏది ఈజీ అయితే అది యూజ్ చేయండి. కొంతమంది టీచర్స్ రిస్ట్రిక్ట్ చేస్తారు ఇలానే డ్రా చేయమని. ఓకేనా? అవసరం లేదండి. ఇక్కడ మనం రే రూల్స్ నేర్చుకుంది ఎందుకు? ఏ 2 రేస్ మనమైనా తీసుకోవచ్చు. ఓకే, అవే కాదు ఇన్ఫినిటీ రేస్ వెళ్తాయి ఇక్కడ. సో ఇక్కడ పిక్చర్ లో మనం వచ్చేసి త్రూ సెంటర్ తీసుకున్నాము. త్రూ సెంటర్ తీసుకుంటే ఈజీగా అయిపోతుంది. లేదు అంటే త్రూ ప్యారలల్ తీసుకుంటే మళ్ళీ ప్యారలల్, త్రూ ఫోకస్ తీసుకుంటే మళ్ళీ ఆఫ్టర్ రిఫ్లెక్షన్ parallel to principal axis. This somewhat difficult. Why? Because you may not draw the parallel ray. There is error. Okay, so that's why. So we are taking through optic center. Sorry, through center. Incident ray is through center. Incident ray is through center. Okay, the incident ray is through center. Then what happens? The incident ray is passing through center. Again it rebounds back and it retraces its own path. It starts from here and it rebounds back. Okay, so now this is the candle object, right? So now where is the image formed? Image formed between F and C. So exactly we get the image where it is formed between F and C, right? See here, image formed between F and C. Okay, so this is the picture. This is the image formation figure when the object is placed beyond C, right? So now we'll discuss about the nature. Image nature. PES. P for position. Where is the position of the image? The total first R1 ray, reflected ray, and R2 I am taking, or R2 or R3, whatever it may be. So this we have taken this as R2. Second ray, second incident ray, reflected ray, and first incident reflected ray, they meet at this point. So this is the point of intersection of the reflecting rays. So at that point image will formed. Where what image will formed? The two rays are starting from where? Tip of the object. So that's why here also tip of the object will be formed. Okay, tip of the object నుంచి రేస్ తీసుకున్నాం కాబట్టి మనకు వచ్చింది ఇక్కడ tip of the object, right? So now this is the nature. Position finished. Size, here we have taken 3 centimeters. You will get 1.5 centimeter. Once you check it, you will get approximately. Okay, so from that, size is big, size is small, size decreased, so that's why we call it as diminished. Okay, next, real and inverted. What is the meaning? First you will get the idea about the invert. Invert means what? Here the object is like this, up arrow, but upside down arrow, right? So invert means what? Reverse. In Telugu talakrindulu. Okay, paiki head up paiki undi, ippudu head down అయిపోయింది. So that is nothing but inverted. You can see invert word also, invert word mathematical here, inverse, additive inverse, multiplicative inverse also you can see, right? 2/3 and 3/2 multiplicative inverse. Okay, so now this is the picture. So real means what? Next one is real. Real means what? This is the image of the candle. Candle image is formed on the screen. Okay, if you observe image of the candle, this is the object, image is formed on the screen, on the paper. So this lab activity also there in our channel. Once you see, go to the playlist reflection of light at curved surfaces. So total candle flame only, not candle, only candle flame only, it is formed on the plain paper. So that's why image is formed on the screen. That's why this is a real image. Real image means the image which is not formed in the mirror. మిర్రర్ లోపల ఫామ్ కాదు. ఎగ్జాంపుల్, మనం ఫేస్ చూసుకుంటున్నాం మిర్రర్ లో, మన ఫేస్ మిర్రర్ లోపల కనిపిస్తుంది, పేపర్ మీద కాదు కదా, స్క్రీన్ మీద కాదు కదా. స్క్రీన్ మీద కనిపించే ఇమేజెస్ అన్ని రియల్ ఇమేజెస్. ప్రొజెక్టర్, సినిమా థియేటర్, స్క్రీన్, రియల్ ఇమేజెస్. ఐ హోప్ యూ అండర్స్టూడ్. వీఆర్ గోయింగ్ టు ద నెక్స్ట్ స్లైడ్. ఆబ్జెక్ట్ ప్లేస్ రేట్ C. Concave mirror image formation figures. Here what we have to do here? Object we have to take at center, right? So object I am taking just 2 centimeter distance. Object at center. So in this case, most of the students get diagrams not proper, image also at C, but what you will do means, what you will do, you draw object and image at a time. Okay, how much is the object and image also the same, draw the at the same time, then after parallel ray through focus. Okay, and see here, just I am drawing with free hand. See, incident ray is parallel to principal axis. Okay, then after reflection it is passing through focus. R1 parallel ray. Next R2 incident ray is through focus. Then after reflection parallel to principal axis. Okay, so here this is the ray diagram R2, R1 and R2. Right, so why I am not using scale here means, here this is the digital board now, that's why some measurements are different. This image is diminished, so that's why changed, compressed, that's why I am not getting. So simply first object and image say take at a time, 2 centimeter up to 2 centimeter down, then parallel ray through focus parallel ray, then you will get the clear picture. Okay, so from that what we can say, here, image distance and object distance both are same, and object distance, image distance same. So image nature, object position at C, image also formed at C. Next to size, what about size? Object size and image size both are same, right? Next real and inverted, the image is formed on the screen and it is reversed, so that's why inverted. Okay, I hope you understood. Next, object is placed between F and C. Object is placed between F and C. Object is placed between F and C. I'm taking object here. Sir, at what distance I have to take? Here this is 2, this is 4 now. At to take at 3. This is 2, this is 4. 2, 3, 4. And you will get image also nearly 6. Okay? Right. Next. What we have to take here now? How to draw the ray diagram? Parallel rays. First R1 ray is parallel to principal axis. R1 ray is parallel to principal axis. R1 ray is parallel to principal axis. Incident ray is parallel to principal axis. After reflection, it passes through focus. After reflection, it passes through focus. After reflection, it passes through focus. I have to extend it. Next, one more ray through focus. Incident ray is through focus. Incident ray is through focus. So R1 and this is R2. If incident ray is through focus, then after reflection, reflected ray is parallel to principal axis. Okay, so here don't do mistake. For example, this reflected ray is not passing through focus and we'll get the mistake. Right, so exactly we have to take through focus only. Through focus. You get image B on C. Okay, so like this you'll do it, definitely you'll get the image. Little bit, so B and C you will get the image. Okay, object between F and C, image B and C. By using scale, pencil, you will get clearly. Okay, so I hope you understood. Children, change dimensions, change. Okay, next slide. Object at focus, parallel ray Incident ray parallel ray after reflection passes through focus. Next one, incident ray seems to coming from center. It seems to coming from center, and after reflection, it is passing through the center. So we'll get the both the parallel rays. So from this figure, what we can understand, we get parallel rays. They may intersect at infinity. They may intersect at infinity. అనుకుంటాం అంతే. Parallel rays they never meet, but అవి intersect దగ్గర infinity distance లో meet అవుతాయి అనుకుంటాం. బట్ యాక్చువల్ గా ఇక్కడ వచ్చేసి parallel rays meet అవ్వవు, బట్ infinity దగ్గర meet అవుతాయి అనుకుంటాం. బట్ మనకు ఫస్ట్ కేసు ఉంది. ఫస్ట్ కేసు వాటి ఆబ్జెక్ట్ ఎట్ ఇన్ఫినిటీ, ఇమేజ్ ఎట్ ఫోకస్. ఆబ్జెక్ట్ ఎట్ ఫోకస్, ఇమేజ్ ఎట్ ఇన్ఫినిటీ. సో యాజ్ పర్ ద టెక్స్ట్ బుక్ యూ హావ్ టు రైట్ ద ఆన్సర్. ఇమేజ్ నేచర్, పొజిషన్ ఆఫ్ ఆబ్జెక్ట్ ప్లేస్డ్ ఎట్ ఫోకస్ బట్ ఇమేజ్ ఫార్మ్డ్ ఎట్ ఇన్ఫినిటీ. Sizes highly enlarged. So the distance from the principal axis, tip of the object is going down. So that's why so highly enlarged. Real and inverted. Okay. Concave mirror. Image formation figures case 6. Object placed between P and F. Right. So now object I am taken between P and F. The first ray rule. Parallel ray we have to take. Parallel ray. Incident ray is parallel to principal axis. Then after it passes through focus. Next ray through focus not possible, right? So that's why what we have to take through center. Incident ray seems to coming from center, right? So this is the incident ray seems to coming from center. So after reflection it passes through center. Okay. So this is the reflector rays. These two are the reflector rays. So reflector rays, in this case we got a diverging rays. Diverging rays, because of diverging rays we have to extend it back with the dotted lines. We have to extend it back with the dotted lines where they will meet. Once you also coincide along with, most of the students will do the mistake this one only. So first you coincide this scale with this ray, reflector ray. Then after draw the dotted line where they will meet. They are meeting at this point. Okay. So that's why image is formed. This is the image position. Image is formed here. I hope you understood, children. Object size is small, image size is more. So that's why this is the enlarged image we'll get. In all the cases we got convergent rays. Means after reflection these two rays are meeting at one point. But in especially 60 case object placed between P and F, these rays, two rays we are getting diverging rays. Means they are moving apart from each other. ఓకే, ఒకదానికొకటి దూరం వెళ్ళిపోతున్నాయి ఈ రేస్. డైరెక్షన్స్ కంపల్సరీ, ఇన్సిడెంట్ రే డైరెక్షన్. సో డైవర్జింగ్ రేస్ దే నెవర్ మీట్ ఫర్దర్. ముందు ఇంకా కలుసుకో అవి, వాటిని అందుకే మనం బ్యాక్ ఎక్స్టెండ్ చేయాలి. రిఫ్లెక్టెడ్ రేస్ బ్యాక్ ఎక్స్టెండ్ చేయడం వల్ల మనకి దే ఆర్ లుక్ లైక్ కమింగ్ ఫ్రమ్ దిస్ పాయింట్, దే సీమ్స్ టు కమింగ్ ఫ్రమ్ దిస్ పాయింట్. సో దిస్ is maybe starting point, that's why the image is formed there. So our eye, by seeing with our eye, the image of this object will appear in the mirror. So now the image is formed in the mirror, that's why this image is virtual image. So now we'll discuss about the nature of image. Very important 6 case. Image nature. P as police station, P for position, object position between P and F, image position behind the mirror lopala padindi, mirror venakala or mirror lo inside the mirror, image position. P position. S size, how is the size? Object size, image size. Image size is enlarged. right? Enlarged we can say magnified also. So వర్చువల్ ఎరెక్ట్ ఇప్పుడు వచ్చింది అన్న మనకు వర్చువల్ ఎరెక్ట్ అనే పాయింట్. వర్చువల్ అండ్ ఎరెక్ట్, వర్చువల్ అంటే ఏంటి, మిర్రర్ లోపల కనిపిస్తుంది, ఇట్లా డాటెడ్ లైన్స్ మిర్రర్ లోపల రేస్ ని ఎక్స్టెండ్ చేస్తే కనిపించేది మనకు వర్చువల్. అండ్ ఎరెక్ట్ మీన్స్ వాట్, చూడండి ఇక్కడ క్యాండిల్ ఫ్లేమ్ అప్ ఉంది, ఇక్కడ ఇమేజ్ లో కూడా క్యాండిల్ ఫ్లేమ్ మనకి అప్ వచ్చింది. ఓకే, సో దాట్ ఈస్ నథింగ్ బట్ వర్చువల్ అండ్ ఎరెక్ట్. ఓకే, ఐ హోప్ యూ అండర్స్టూడ్ దిస్ image formation figures of concave mirror. Next slide is about object placed at infinity, convex mirror image formation figures. Yes students, here first object placed at infinity means first thing what we have to do, we have to take parallel rays. Object at infinity means obviously we have to take parallel rays, incident rays parallel to principal axis. Okay, then what happens, incident rays parallel to principal axis. After reflection it seems to coming from focus. After reflection it seems to coming from focus. చూడండి ఇక్కడ చాలా మంది మిస్టేక్ చేసేది ఏంటి, ఫోకస్ తో కోఇన్సిడెంట్ చేయాలి. ద పాయింట్ ఆఫ్ ఇన్సిడెన్స్ ఫోకస్ విత్ ద హెల్ప్ ఆఫ్ స్కేల్, అయిపోయింది. సో దిట్స్ అ గుడ్ థింగ్ ఫర్ యూ. డైరెక్ట్లీ స్కేల్ తో చూపిస్తున్నాను మీకు, స్కేల్ తో మనం ఫోకస్ కోఇన్సైడ్ చేస్తే ఈజీగా వచ్చేస్తుంది. కొంతమంది ఏం చేస్తారు, ఇలా గీసేస్తారు, వెనక డాటెడ్ లైన్స్ ఇష్టం వచ్చినట్టు పెట్టేస్తారు. పెట్టేసుకోండి అన్న, మీకే కదా ప్రాబ్లం, చెప్పండి. కరెక్షన్ చేసే వాళ్ళు ఏం చేస్తారు, రాంగ్ చేసేస్తారు. చూడండి, ఐ హావ్ టు డ్రా ద రిఫ్లెక్టెడ్ రే. సో దిస్ స్కేల్ అదర్ ఎడ్జ్ షుడ్ బి కోయిన్సైడ్ విత్ ద అదర్ ఎడ్జ్, కంపల్సరీ కోయిన్సైడ్ అవ్వాలి ఇలాగా. ఓకేనా, సో ఇప్పుడు మనం వచ్చేసి మిర్రర్ అనేది రిఫ్లెక్టెడ్ రే వీ కెన్ డ్రా ఫర్ దిస్. ఫోకస్ అండ్ పాయింట్ ఆఫ్ ఇన్సిడెన్స్ కోయిన్సైడ్ అవ్వాలి. ఓకేనా, see now, very good picture. These two are diverging rays, that's why diverging mirror. Diverging rays means they never meet again. వెళ్తూ ఉంటే దూరం వెళ్ళిపోతూనే ఉంటాయి, వాటి మధ్యలో డిస్టెన్స్ అనేది సపరేషన్ ఇంక్రీజెస్. డిస్టెన్స్ సపరేషన్ ఇస్ ఇంక్రీజెస్, రైట్? డిస్టెన్స్ సపరేషన్ పెరుగుతుంది. డైవర్జింగ్ రేస్ ఎవరు డ్రా చేసినా సేమ్ వస్తాయి ఫిగర్స్. ఓకే, ఎందుకంటే మన రేడియస్ 4 cm కాబట్టి ఫోకల్ పాయింట్ ఈజ్ లొకేటెడ్ అట్ 2 cm. Clear picture, we got it. Okay, right. Next, what about the nature of the image? PS position, object position at infinity and image formed at focus. Who said focus దగ్గర image form అయింది, ఎవరు చెప్పారు? Diverging rays ని back extend చేస్తే they are seems to coming from focus. Diverging rays they never meet again, they start from a focus, they start from the object, that is the image position. That too point size image is formed, that's why highly diminished point size image. And virtual and erect image, this virtual erect image we will understand in the next case, right? See here, case 2, object placed in front of mirror. Object mirror ముందు తీసుకున్నాము. ఓకేనా, జాగ్రత్తగా అబ్జర్వ్ చేయండి. ఆబ్జెక్ట్ taken in front of mirror, right? సో ఆబ్జెక్ట్ మిర్రర్ ముందు తీసుకున్నాము, ఎలా వస్తుంది ఏంటో ఒకసారి క్లియర్ గా అబ్జర్వ్ చేద్దాం. ఓకేనా, సో ఫర్ ఎగ్జాంపుల్ యాజ్ పర్ యువర్ హైట్ 3 cm ఆర్ 4 cm టేక్. ఓకే, సో మిర్రర్ కి చూడండి కొంచెం ఇంత హైట్ లో తీసుకుందాం. ఓకే, నెక్స్ట్ వాట్ వీ హ్యావ్ టు డూ, ఫస్ట్ వన్ ఆల్వేస్ ఫస్ట్ రే రూల్ ఈస్ ప్యారలల్ టు ప్రిన్సిపల్ యాక్సిస్ కదా, ప్రిన్సిపల్ యాక్సిస్. సో ప్యారలల్ తీసుకోవాలి. ఇన్సిడెంట్ రే ఈస్ ప్యారలల్ టు ప్రిన్సిపల్ యాక్సిస్, ఇన్సిడెంట్ రే ప్యారలల్ టు ప్రిన్సిపల్ యాక్సిస్. ఆఫ్టర్ రిఫ్లెక్షన్ ఇట్ సీమ్స్ టు కమింగ్ ఫ్రమ్ ఫోకస్ కదా, ఫోకస్ నుంచి డైవర్జ్ అవుతుంది. చూడండి, ఫోకస్ 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 కంపల్సరీ ఇక్కడ కోయిన్సైడ్ అవ్వాలి. ఈ పాయింట్ ఇది కోయిన్సైడ్ అయినాకనే ఇలా గీయాలి, అంతే కదా, ఎంత సింపుల్. చూడండి, ప్యారలల్ రే ఆఫ్టర్ రిఫ్లెక్షన్ డైవర్జ్ ఫ్రమ్ ఫోకస్, దిస్ ఈస్ ద R1 రే. నెక్స్ట్ R2 రే, ఇక్కడ 2 రేస్ డ్రా చేయొచ్చు. సో నా సజెషన్ ఏంటంటే డైరెక్ట్ సెంటర్ తీసుకుంటే బెస్ట్. డైరెక్ట్ సెంటర్ తీసుకుంటే అయిపోతున్నాను. ఎప్పుడైనా మీరు సెంటర్ నుంచి తీసుకున్నారా, ఒకటే లైన్ గీస్తే సరిపోతుంది. చూడండి, ఇక్కడ సెంటర్, ఇక్కడ టిప్ ఆఫ్ ద ఆబ్జెక్ట్ మ్యాచ్ అవ్వాలి. చూడండి, హియర్ సెంటర్ అండ్ టిప్ ఆఫ్ ద ఆబ్జెక్ట్ మ్యాచ్ అయింది. ఇన్సిడెంట్ రే ఇక్కడ స్టార్ట్ అయ్యి ఇలా వస్తుంది, వచ్చిన తర్వాత ఇక్కడ నార్మల్ తో కోయిన్సైడ్ అయ్యి వెనక్కి వెళ్ళిపోతుంది. ఓకేనా, ఒక్కటే రేతో ఖతం అయిపోతుంది. Incident ray is towards center, after reflection it rebounds back, but one more thing, we have to keep the dotted lines here also. Inside the mirror we have to keep the dotted lines. So now these two are diverging rays. Those are diverging from a point. That point is the image point. Okay, that point is image point. We have to draw image, right? Addition. I hope you understood. Are you enjoying, children? See here. Image is formed at focus. No, image formed between pole and focus. Children, concave mirror, 6 cases there, but convex mirror only 2 cases. Object at infinity. Okay, this is very important for the convex mirror. Where object placed in front of mirror, we get image diminished and image also formed in the mirror, right? And image position between P and EF. I hope you understood, right? So object beyond C. This is object distance. Nature of the image. Image is formed P as police station, position, size. Position of image. Image formed between pole and focus, and size diminished. So object here we have taken, for example, 3 centimeter, image 1 centimeter or 1.5 centimeter only, we got it. Next, virtual and erect. Virtual means what? The image which is formed in the mirror, or image is formed due to diverging reflector rays. Next, erect image. Object. See that candle flame upward. Here image also candle flame upward only. Invert means reverse flame, right? Up arrow, right? So successfully image formation figures completed, ray rules discussed. I hope you understood, right? So for this my hard work, you should give the credit, subscribe to our channel, like the channel, and that is the motivation to your answer. Give the encouragement to me and like and share, subscribe. What is your opinion? Comment, right? So I always help you be connecting with Raj sir. Okay, we have any slides? So this is the last slide, right? Thank you. Compulsory should write the notes, then only it is very easy. Okay, I'm signing off. Bye bye.